Okay, this is going to be a little bit tricky, but first let's pick up our pink sheet. Remember, it's area for parallelogram. Let's quickly cut out the pink sheet so that everyone can get their shape. Cut out your parallelogram, but please don't glue it yet. We have another step we need to do before we start gluing this. So don't glue it yet, just cut it out. Now take the parallelogram that you have and let's trace this first, okay? So I'm going to take my parallelogram, okay, and on this corner, okay, leave some space around it, but try to trace it. See, most of you have traced your parallelogram. Now look at this. Remember I talked about how good mathematicians try to find out what they don't know from what they already know. Is there a way you can turn this shape into a shape that you know a lot about? Okay? Is there a way you can turn it into something that you already know the area for? Okay? So think, if you were to cut this shape and try to rearrange the pieces, how can you make this into a shape that you already know about? And before you start cutting, I would like you to take about 2 minutes and talk with your table group. What should be your strategy here? What should be the plan? What do you need to do? How can you make this parallelogram into a shape that you know a lot about? Okay, go ahead and discuss. How do you think you can make it into something you already know?
We can cut it in half.
You will make congruent triangles? And what will you do with the congruent triangles? Do you know how to find the area of the congruent triangles? So think, what else can you do? What can you do? And what would you do when you get to that?
I would have a rectangle.
Oh, that will make a rectangle? Oh, and you already know how to figure out the area of the rectangle?
Yeah.
Okay. That's a good strategy, Monica. Good thinking. Who would like to share? And actually, I would like to invite Monica first, because she had an interesting idea what she would like to do with her parallelogram, and then all of you are more than welcome to share what your ideas are. Remember, yesterday we realized everyone can have a great strategy, okay? Let's start with Monica. Monica, what do you think we should do?
I was going to cut off these sides of my parallelogram to make it a rectangle so I can find out the area.
Okay, you were going to cut out the sides to make it into a rectangle. Are you cutting out both the sides?
Yeah.
Okay. And does anyone have another idea? And why are you doing that? Because you already know how to figure out? Okay.
Rectangle.
The area of a rectangle, okay. And does anyone have another plan? What can we do? Maritza?
My idea builds upon Monica's. I think if we cut off the edges, maybe we can connect the edges to make another like square rectangle.
You think that it's possible? And thanks for using excellent academic language for saying that your idea builds upon Monica's and that you can cut off the edges, okay? That's an excellent idea. Anyone else? Okay, let's try and see if that is really possible. Go ahead, cut and see if you can move the pieces around and make it into something you already know about. Was anyone able to move their able to move their pieces around to form a rectangle? Raise your hand if you were able to find a shape by moving your pieces around from the parallelogram that you cut. Okay, was anyone able to? Okay, let's try and see. Look at my parallelogram up here. I had shape A. Remember, I had traced it before. And now I cut just one piece off, and I'm going to move this piece to this side. And if I move it down, what shape do I have? Is it a rectangle? Yeah, rectangle. What shape do I have? I have a rectangle. But there's nothing wrong if you actually want to cut off both the pieces. Look at this one, okay? Some of you might feel like you want to cut off both the pieces, which might not be necessary, but you can still do that, okay? If you accidentally cut both the pieces like Lysander did, it's still okay. You know, it's really about how can you move these pieces around and rearrange them to get a shape that you know a lot about. So go ahead and glue your rectangles right below the parallelogram that you traced on this sheet of paper. Go ahead and now glue it. I know that all parallelograms can be made into a rectangle. Okay, because this is what it's showing you. Look at the D shape that I had. I cut it and I also made it into a rectangle. That was my parallelogram D. All parallelograms can be changed and made into a rectangle. This means that area of a parallelogram is same as area of a rectangle. This is what we found out. This is what you just derived, that area of a rectangle and area of a parallelogram, they are the same. Okay, they are different shapes, but we can move them around, but the area still is the same. Now let's look at my parallelogram. What is this side called? Okay, remember my parallelogram, let's label it A, B, C, D. What is this side of the parallelogram called? What would be this, Samson?
Base.
It's the base, or B, and most of you now know base, B. Where's the height of my parallelogram? What would be the height of my parallelogram? Who would like to share? Where's the height of the parallelogram? Marissa?
The base,
Height.
the height, it would be up here.
This would be my height. Imagine, and I'm a really tall person, if somebody was trying to find my height and I was kind of standing this way, sideways, would you be able to get my right height? No. Would you be able to measure me correctly if I'm slanted and going this way? And we talked about this yesterday. In order to be able to find height, how are you supposed to be standing up? If someone's measuring you to see how tall you are, how do you need to be standing up? Nikki?
Straight.
And what does straight mean in this case? How do I need to be at right angle, which would be a 90 degree angle, which would be perpendicular. So this cannot be my height. And a lot of times on your test, they'll give you this side, the measure for this side too. That's just a trick question. Remember, your height would be right here. You can draw a dotted line, or you can start from this end and draw it down. Remember, this is making your 90 degree angle here or here. So your height for the parallelogram would be right here, this line. And I can probably use another color so you can see better. I'm sorry. Okay. Look, this is the height. Okay. If this is the height, this would be the base for my rectangle. This is the height for my rectangle because it's at a 90 degree angle. Okay? Can you use this information to find out how much is the area of this parallelogram? Because we know area of a rectangle is going to be the same as area of a parallelogram, or area of a parallelogram is the same as area of a rectangle. And we know the formula for area of a rectangle. A equals B times H.
Is the unit still centimeters?
The units will be for the length of the sides. It's still a centimeter grid. That means yes, the units will be still in centimeters for if you were trying to measure the sides. Okay, so let's try this. This is 1, 2, 3, 4, 5, 6, 7. So my base is 7 centimeters, and 1, 2, 3. The height is 3 centimeters. Okay, and let's see if you can figure out the area of your rectangle. And in this case, area equals 7 times 3, or 7 centimeters times 3 centimeters. Area equals 21 square centimeters.